Okay, my name is Peter Rossbach. I'm system architect, freelancer, founder of a very small company based in Bochum, B242 Solutions, and I know solutions. A lot of us. I'm a very old man, I hope. I can present now my experience for the last 2 years about Docker ecosystems and use it as to deploy, implement, develop, hate some microservices. That's my motto. I'm not perfect, but I hope I can learn to be perfect. For now, more than 10 years, I have seen a lot of monolithic applications. I'm a Java developer. And all guys of you know Java. With Java, you can create brilliant monoliths. And you have these pattern in production, a lot of you guys. And now we use to change the world in split the applications in smaller pieces that you can easier deploy, change, faster develop, better understand, freedom of your choice of technology to split your database in a lot of NoSQL databases. But I know in my history, distributed systems to create is a very hard job. It's not so easy to go from this architecture in this world. You need a lot of help and environment, and it is more in your organizational revolution than an evolution. You must rethinking a lot of things, not only technology-based. It's more a mindset. You must shift people, and that's a hard job, and you must find a clearer solution for technology. You need a platform to deploy your pieces of software. You need you must change your developer strategies. And the real challenge that I detect by my customers is that they want to make software faster available. As they want higher quality. And that is a funny story. You say to the developer, you must be faster, and you must, at the same time, you must deliver higher quality. And the only chance to do that, I think, is to automate things. But to build automates is a hard job. And it can be a harder job than the business problem that you must solve. And the other things that a lot of my customers do currently is to make their services globally available. And that's the next choice, to must deploy your services in the cloud and not in your data center. And that can be a real challenge. And the other things is that a lot of my customers want to learn from their customers, how they use these services. You need metrics in every things, not only in the technology things, also in your business side. And you must reduce cost. And you know all these things, quality, faster available, better cost, they want all. and that is a real challenge now, and we must build clever automate to do these things, I think. And what I are a very fan from is this DevOps community and what you can learn from these guys. And that is what I do every day. I build my software, I ship it, I run it, and I automate all things. When it is not automated, I hate wikis. I use scripts, and you must push a lot of tests to do that. You cannot automate things that you have not are testing your software. And you measure all things. And you must then, at the last thing, then you have a pipeline, a strategy found, you can change things very fast. But at the start, it's these 3 items. You must innovate in this to build, ship, and run software. And that last point means developer ops. And that is a real good practice. And what I found for now more than 2 years is Docker. And I want to show you some experience that I do in my daily work with Docker and which tools that I used and how can empty it. Which from you guys use Docker in a daily work base? Who not? Why? Why? It exists no better option for deploy software than Docker. It's the best packaging format ever that we found in the IT. And this mantra, you must go every time you go on outside of your bed in the morning, you must tell the story. Build, ship, run, any app, anywhere. That is your mantra if you leave this room. And what is the simple answer of Docker? It's fascinating me every time. It's a very, very funny solutions that we have or can have for more than 50 years or so, I think. It's a very simple story of golden image. You package your software in a production-ready format that you can ship to a registry that every host of you want to deploy this piece of software to deploy this host. That is the story. It's a simple packaging format to isolate software on one host and share this with very tiny tar format and a very clever extractor to isolate root files on Unix. And that's it. It's a very simple idea. And when one of these guys say, okay, have these questions, these very, very stupid questions, is Docker production ready? Yes. It package your software. Is your software production ready? Then you can package this with Docker. Docker is not in between your software and everything. Your software used and is only a packaging format. And what that really means is that your software, you bundle it on your Mac with the virtual machine on Linux. It's the same binary that is used in production, with all the dependency packaged inside these file format. And that means this your software is used with the same functionality, same versions of all dependencies, with your file system that you choose, your user that you are configured in your bundle library. But the only differences can be the Linux kernel. And that can be a problem. If you need some special functionalities, you're packaging your UI applications with a special UI driver, device for NVIDIA cards or so, then that can be a problem. But on the normal microservice world, it is no problem. You have a simple algorithm, you're packaging your algorithm, your language virtual machine like Java, and the reality is you can think in infrastructure first. You can put all your pieces that you have in different Docker containers, putting them together, and have a functional, rich microservice platform or whatever you want. The reason is on Docker is that you pre-package your applications in a container. The best practice is you put one application in one container, but you can have multiple containers. I have heard here from unikernel now this talk, and it's very fascinating that Docker now by unikernel language that you can also bundle a kernel features that your application used in one container, and that's the future, I hope. But you can also reuse some binaries, libraries from your host operating system when you need them. The Docker is only a management layer. It's a management layer for your processes that you start. That's all. And what you can also configure is isolation, file system, networking, users, IPC calls, UTS, all the namespacing stuff in Linux, and you can use the security option of your OS, like SA Linux or capabilities, and in the newest version, seccom conform access policies that you have a really secure process. And it's a real good idea from Docker to invest in these areas that we all have can start different processes on one kernel with security inside it. It's better than we do it now. this isolation thing from Docker is better that we use in the normal deployment stuff, what you do with your configuration management tools or so. And the other thing is that it's a cache for these Docker images and use some very clever libraries to integrate all these Unix stuff. That is the lib container library and the lib networking library to build multi-host overlaying networks and have open source projects for these registries that you can have a public one or your own one in your company or for your customers also. And I think after these 3 years now of these Docker projects, Docker is now the first very public accepted container technology. It's the standard. And that's very good. It's a good news that now we can say, okay, we have one standard, not tens or so as before. Nobody accepts that. And what is the Docker offering tool set that we can use? This is our Docker engine, that is the daemon, a toolbox for developers that you can have it on your Windows or Mac OS with all these tool sets. Docker machine is a tool to create machines and clouds and public virtual machine products. And with Docker Swarm, you can define constellations of Docker containers that run as a service. It's a runtime description framework. And putting these pieces together means you have this main guideline, you can build your images, and you can push these images to the registry, and the Docker daemon are loaded to one host. On every host, it exists one daemon to load all these Docker containers. And on the other side, who you build your hosts. And that is the project Docker machines, that you can build a Docker host, a very limited, in normal way, a very limited Linux distribution. Like the toolbox used boot Docker. In productions, you used Core OS or Ranger OS, or so a tiny Linux, a very stripped down Linux distribution. And on the other side, you have this Docker Swarm. It's a scheduler to maintain multiple machines that you can address your containers on which host which container are started. And with Docker Compose, you describe those situations that you can have a stack, like a UI or container with Node.js, and in backend, some Tomcat thing with REST services inside it, and in the backend of the Tomcat, some caches like Redis or a regional database like Oracle, MySQL, or a NoSQL one, Cassandra, MongoDB, or whatever. And then you can start those constellations. Yeah, Docker machine, Docker engine has all things inside it to manage resources, to give a process a limited access to memory, CPU, block I/O, net I/O, to manage these constraints. And on the other side, to attach volumes that different containers on the same host can share some data or have some temporary read-write storage to attach to one containers. And on the other side, network management, that you can attach a lot of containers on different hosts at the current moment to communicate in a limited network that only sees these containers. You can have some containers that cannot contact other containers on the same network. And you can have some information to process configurations like environment parameters or metadata with labels. And the Docker daemon handle all these loading of images and monitoring stuff like metrics and logging, how much CPU or memory I/O your container consumes, your processes. That is what the Docker engine do, and Docker machine is to create Docker machines, to have a base image and push it to a hardware, make it available with a Docker daemon for you. And it has a plugin driver, so you can build your own provisioning Docker machine strategy, or you have another provider that is not supported. Currently, it's supported a big cloud vendor like EC2, Microsoft Azure, or your local machine, VirtualBox, or VMware, vSphere, Rackspace, OpenStack, Microsoft Hyper-V, a Google Cloud Compute Engine, Exascale, or a generic one. Then you need, you make your provisioning as before, and you share a SSH key with the Docker machine, and then you can install the Docker daemon on this host to manage it in a manner. Docker Swarm is a project to schedule Docker containers to multiple machines. This is the real benefit of Docker. You have a management engine on every host with the REST API, and it's very easy to maintain with curl. It's a curlish interface. Docker Swarm is a proxy for many of those Docker daemons. Choose which machine can start this container, and you can choose some strategies to schedule your jobs. Like another one is Mesos, Marathon. You can use also. Docker Swarm is one that's supported from the Docker community. And another thing is you can use multiple discovery services. Discovery services need to identify which machine is accessible from this swarm daemon. That is the reason behind these discovery services. It's not for services like containers or so, it is also for registering the machines that can be used in your swarm. And then you can use some filterings, affinity and constraints to schedule your jobs on multiple machines. And it's a very open API, and you can integrate some plugins. And currently it is master-slave cluster support. No? You can have one master that schedules jobs, but you can have some fallbacks that you can boot those swarm proxies that you have a stable version of this service, of this swarm service. And what you can do with Swarm is rack management. You can say, okay, I have some machines in DigitalOcean, some machines in Amazon, some machines in my data center in OpenStack, and some development stuff on my notebook, and it can be controlled by one Swarm proxy. And then you can schedule your Docker containers to all these machines and have a central point of control. And how it works a little bit deeper inside these Swarm proxy, it is a Swarm manager that makes the scheduling job possible, that needs the service discovery to get information which agent is available on the Swarm, and which which Swarm or Docker engine you can address. And this Swarm manager get all the information which container is running on this box and how many resources this container is consumed, and then you can make a scheduling decision on some labeling. You can label your Docker engine, your containers, to make it possible that the scheduler can formulate a right constraint on which box node these containers scheduled. Then you can have some front-end boxes and some back-end boxes and some boxes that need a lot of memory for caching or so. And then you can say, okay, I want to schedule this next Redis drop to this caching area on my swarm. And Docker Compose is to formulate those scenarios, to have a description format as runtime for a scenario that you want to start. A lot of Node.js, Go programs or Java processes with the backends inside it. You can define service groups, and it support also Swarm. And you can attach to one container multiple networks. Networks that is available only on one box, or overlay networks that is multiple hosts to span a network, a virtual network, about all your boxes. And here's a simple example of a Docker Compose file. I have a tiny Java program, build it with Maven, put this Docker Compose file so I can run my script. I build my thing. A little bit later I show how I build our Docker image, and then I use a Tomcat to support my web applications and build it. And my Tomcat, these applications need a MySQL database. And then I say Docker Compose builds, I build my application, package it, and then I can start with Docker Compose up, and these scenarios, these 3 containers are start up. And the startup needs milliseconds. Okay, MySQL and Tomcat need a little time to initialize. MySQL need 2.5 seconds. A big Java application needs 10 seconds or 20 seconds. It depends on your processing power. And it exists an option, scale my Tomcats. I can scale my Tomcats on multiple machines. If my swarm supported it, then I can say, okay, I scale this service on multiple boxes. It's not auto-scaling or so support currently implemented, but it used these tiny dialects that you can, as developer, make these experience. How scalable is my application server? It is very important for me not have in mind that only the production side. I must, as a developer, I must develop those things at my laptop. It's not useful that the complete scenario only is used with this production side toolset. I need a toolset that I can use as developer, also as on the production side, the same development toolset. And that is what I learned on this side, on Docker. It's very useful in this area. And a Docker file for a Java application is very, very simple. For a Spring application, as example, it's very simple. You add your Java base image, add some logging configuration to it, a run script that you start your Java process and push your jar file in it, and then you can start it. It's a very simple description. And if your description is complicated, you are wrong. You want to build microservices, simple things. If you need a lot of description file, think about splitting. The run job, as this example, start, it's Java 8, you need this for Tomcat security identification, need this urandom parameter in it, I need a logback configuration, and then you can start your jobs, that's enough. And then you can push these results to the official Docker Hub in a private repository or an open one. It depends on your choice. What you want to make an open source project or a closed source project, and then you can add it as a pre-built, and then you can, it is available globally. It's an SDN network based on this Docker Hub, and it has automatic build pipelines on it. When you only need these Docker file to build your software, then you can do that automatically. If you checked in, it's automatically built. And it's very successful. It has more than 100,000 free repositories. Now it is 1 million. It doubled in the last half year, this pool. It's very successful. And you can buy an on-premise version from Docker Inc., this Docker Trusted Registry, or Artifactory has a support for a Docker registry also, or you can use another cloud service from Google or CoreOS or IBM. It exists more options on that. The networking thing is very cool. It's very easy to build virtual networks. Who is in the room as an operator and build virtual networks? Nobody. We are all developers here. Nice. That's for us. It's a very fine abstraction. You say also, I built my Docker network, and it's built overlay, and then you have an overlay network and can build a network, a green and a yellow one, and it's very sure that green containers cannot communicate with the yellow network, and that's great for us. And it's completely built in the toolset. And that's the very magic things behind the Docker community. It's not so that they have a lot of ideas to build infrastructure components, but they build a very glue around it that we can easily use. This easy use pattern is very cool. In a network stack, it's very hard and complicated to build overlay networks in a normal way. But with Docker, it's very easy. And yeah, it seems good. It sounds good. It is built for microservices, I think so. It's a very clever packaging format. But how I define the real environment, that's my challenge. And I want to see what I built is I built my services on my customer sites currently with Spring Boot, with REST services on it. Very tiny one, and have this architecture. We have some resources, some services that access other resources. We have a domain layer, a repository, a data mapping, and a database. And in my way, we have Cassandra as a database. And we add as a service some monitoring stuff and information stuff. We have a documentation, the API with Swagger, built with health checks and with metrics and logging output. We have a standard base framework for that, a very tiny one. And that's the microservices that we shipped. What we learned is we need a build pipeline. And then we search a little bit, and we don't find them. And then we identify, okay, we have enough knowledge about Jenkins, how we can build a build pipeline, very easy one for the need for these microservices. And we choose GitLab as our local repository provider. And what we want is when we change something in the microservice, we have a simple pipelining steps for compiling, unit test, and packaging. And if this successfully, we create a container and push these container to a registry. That is the first build pipeline. And if this is successful, we have an integration pipeline to make tests on integration level, like API tests, like tests with real databases behind that, and so on. And what we see is we build a lot of microservices. And when you use Jenkins to set up those build pipelines by hand, it's a very boring job. And then we have the next clever idea to build a seed build pipeline. Every time a new project is in the GitLab with a special marking, then we auto-create this build pipeline. And that was a really amazing story for the last month. And that is an easy way to start microservices. We can start microservices in, I think, an hour or so, and it's in production, the first result. It's not useful, but it's in production. We can start these projects, and we checked in, and zack, Hello World is in production. And the customers cannot believe it. And we show that in a 5-minute sketch, and it was in production after 5 minutes, a Hello World. And I say, okay, now I know we have the nice, he say, we have the right boys on these projects. That is really cool. And but the hard part that we identify after integration tests is to deploy it to an environment, to real environment, to make load tests and so. That I think we can solve in the next month. But what we choose is we choose Kubernetes, and I will show a little bit later what Kubernetes is for us and how we use it. And what we learned is that this environment, this core environment, that you can ship your containers and run it, your container platform that you choose for your microservices, needs environment. And what we detect is that these environment need a scheduler, like Swarm, to schedule these microservices to the boxes, that we can easily add new boxes to it, or scale one microservices very easily of a lot of boxes. On the other side, we need a provisioner, like Docker Machine, to set up one of these nodes. And sometimes we need more provisioners that the Docker Machine projects offer us. We need some base services on every box and you cannot do that very easily with Docker machine. But we need a service discovery. We must register all machines and all services very easily, that we can have load balancers, that we can make the services accessible from outside. And we must do it by myself. Nobody offer you an option outside cloud world if you're on your data center, offer a solution for that. You must build it by your own. And that is a hard lesson. For me not, I'm a Tomcat committer, and for 20 years my hobby to build load balancers. And it's easy, but for a lot of guys in my project, it was hard. And on the other side, it is you choose a back-end service for your microservices. You need a very good logging environment to control on which boxes, which services started, and it works journal right or not. And you need add to your service a lot of matrix and health checks, and sometimes you need near-time analytics to your failures. If your delivery pipeline is automatically and your developer don't implement some tests on the right thing, then it breaks all. And then you must react very fast, and you must see it. And to see it, you must build your dashboards. You must choose Grafana, Kibana, whatever dashboarding service you need to make visualizations of your things. And you see, it's more services than I have microservices. That's the first time. It's a complicated environment to build this environment as build these microservices. And that's the strong part of building a container platform, to build all these services around that. And on the other side, we see to identify that all what we want to store in databases or file systems and so is outside of the container platform for the current case. The handling of volumes and so in the current technology stacks are not so stable that the operating guys say, okay, that's enough. We use all storages as the classical way. With classical provisioning steps, it's not containerized, and so we use container in the development time, but we don't use it in production. Kubernetes, what Kubernetes offer us in these projects, it has a cluster scheduler, and that means it identifies of a lot of boxes to schedule container like Swarm that do, but they can detect a failure. You can add some health checking in your descriptions, and the scheduler see, okay, one of your container cannot offer the service or is break down, and they start another one. And it's a newest version, it have some rescheduling strategies to schedule that. But the dirty part is Kubernetes don't support these setup of the base machines that you must do with classical ways, like Packer.io's, CoreOS, created with loading stuffs and so, that you must do by your own. You containerized your images. It's not a built environment. You need Docker for that. We choose Docker. And you must add the container health management, an endpoint, and you must have on a higher level a controller to start and stop those containers. But the nice part is these scheduler things, and that is what we need for these replication things, and it have an own service discovery service inside it. You must build it by its own, and it has a rich description language for services, and that's a good part of these Kubernetes scheduling thing. But the setup is very hard. At the first time, in the first 2 months, we have a lot of problems to set up this a bunch of services on a developer notebook. It's a lot of to start it. You need an API server, you need in service discovery things, you need a process for management, you need a process for scheduler, you need a kube proxy to make your services available on your networking part, you need a kubelet to schedule on every box pods. Pods are groups of containers, and you need a Docker engine on it, and yeah, it's a lot of stuff to learn and to set up, and it's not so easy to maintain. Kubernetes projects are released every 2 weeks. And we have a lot of leak currently in the production side. We use in the development side now the newest shiny version, and in production side we use a half-year-old one. And that is a very thing about to maintain those things. For the operating guys, it's not so easy to change so complex control plans. And what the reason behind is these Kubernetes have another deployment format that use groups of containers as a deployment format. So that you can have replication groups and have a lot of containers on every box is available as a group. And that is a good news for this complication Docker files. I say, okay, you must split things, and that's a good idea, but on the operating side, you must start these things together. And then you need a description for putting those things together. And that is what the pod descriptions is bringing, and all these containers share the same network interfaces. That is one service group that can have multiple services on one group, and you can share some volumes with your host or with your other containers, and you can define it in the description language. Oh, that's not right. And what that currently mean? You define a replication controller for a service, and you can say, okay, how many replicas exist on these services, and then you can define a template. That is what the pod mean, and I can show it on the next slide. And that is what the container mean. You can say, okay, I have this is a description of one container. You have a service. Then you can define some resource limiters and some configuration stuffs inside it. You define the image. The poll policy is sometimes if you start on a new box or an old box, this container with image policy always. They pull the news images from the Docker registry, and then you can define ports on which ports your service is communicated. You can add some volumes, you can add some health checking inside, and you see it's a very rich description languages that Kubernetes offer us. And if you start this replication controller with these pod description inside it, then you can have another description, a service, and that is an offering with a fixed IP address on all your other ports, and you can say, okay, I want to offer my services on every node on this port. That is the external availability. You can also choose a type of load balancer that you define, so the external load balancer can read this information of this service that make this service outside available. That external pieces of your infrastructure can access these things. Yeah, and these availability means that on every box a kube proxy is started, and the kube proxy watch the API server. Each one of these descriptions is offered for them, and then make an IP table hack on it and open the ports to communicate with your pods. And it means if you have make a service node port available, then it is accessed on every machine on the same port and makes these redirects on the IP table level. It's not very fast, but fast enough. Yeah. And that's what that's the external load balancer that we used. We used watch every time the same API server, have a template generator for Nginx, and generate the configs and restart the Nginx process. That's the pattern that we used, and I think what's the most people currently used. And what I do now for you is, after these very fancy project that I do, I have set up a Kubernetes standalone. That is very simple. With one script, kube, you generate a Docker machine locally on your Windows or macOS box, and then you can say kube up, and all the services come up. And after 30 seconds, you have a standalone kube cluster on your notebook, and then you can develop with that. That's a big step. In summary from my things is containerized your service is create really fast value. It's so easy and maintainable. That's great. The other thing is with Docker, deployment of software is much easier as before, but the hard part is create your build pipeline, create tests for that, package the software well. You can do a lot of things wrong with packaging. Deploy and maintain a lot of machines with this software is hard as before, and monitoring all these services is very, very hard. That you have correct representation what your real software is doing. I learned in the last 2 years a lot of dynamic infrastructure with these pieces of software, and I hope I inspire you that you can learn a lot of that. And these are the projects that I used: Kubernetes, Docker Swarm, Mesos, the Google engine, and the Amazon engine. You can a lot to learn what they do. And also, these containerized software is built for clouds, for industrial IT. And I do it in a daily business. But you must change your organized structure. And you need hardcore IT knowledge. If you don't have hardcore IT knowledge, and I mean hardcore IT knowledge means you must use shell. And you must learn it well. And you must learn a lot of OSs and so. And that can be a hard part in your team. And the other thing is these ecosystems is growing very fast and moving fast. Something that you learn in a month before, after 2 months later, another project comes on board and make it better. And that is a challenge. And don't forget monitoring, design for failure, set up machines, handle persistent stage. That's a real amazing story. Your developer need a product-like environment. Yeah, I package all my slides in container. You can, if you're Docker aware, you can read it very easily and can use these fine flipping presentation. The boring of us read the PDF. It's on my speaker deck account, and it's available now. Directly, it's shipped for hours or so on this network. Yeah, now questions. Yeah.
Thank you for the presentation. Can you go back to the delivery pipeline 1 second?
Yeah. I hope it's in this area. No. Yeah. Yeah.
Yeah, here. On every change to the source code, you create, I guess, a new Docker version. Maybe a new version for every feature branch that you push.
Yeah.
Yeah?
Yeah.
And then you run the unit testings, you create the package and push the image to the container registry. And then you said that you run the integration test. But what if the service that I want to deploy has to query another service, has dependencies on another services? How do you bring all the environment up to be able to test that service? You know what I mean?
Yeah, yeah. That is one of the complete stories. If you have a lot of services tied together and you build all these services at one point, and sometimes we use for this scenario some moving tags. So we have one. Sorry. In Docker space, it exists mutable and immutable tags. Yeah. and you can move these tags, the latest tags, with the latest build. And then on the integration test, we use in one sprint, we use these moving tags, but we tag all our images with the GitHub revision number that we can rebuild these scenarios at the time. Yeah, but on the build side, those tests with other services, and sometimes we pick one hard version. Another time when we develop on two services at the same moment, then we use these mutable tags for that.
The problem I found is that I want to deploy the service A, and I need the service B, which has a database. Yeah. So
it's complicated.
Not sure how to. Yeah.
Sometimes you are a little bit irritated which version you really use, but we log these versions, and then it's not really repeatable, but we can analyze it, what we changed on the GitHub side, on the log side, on the history. We don't use big Git commits. We use very tiny ones, and then it's very traceable for us.
For versioning the container, you just have an incremental number?
No, we use the revision number of the Git repo.
Yeah, but the GitHub repo uses semantic versioning also for microservices, or what kind of versioning?
We use these revision numbers, but also we use our incremental number also.
Okay.
Yes, both. And also we integrate all these meta information with labels in every image, that you can read it at runtime. It's not only the tag, it's also the name, the copyright, the license, and the complete stuff is inside the meta informations currently.
So one thing I don't get here is that at the beginning you say Docker is easy, we should use it. And then half an hour you explain a lot of complicated, lots of moving parts. Yeah. At the end you say, we need hardcore IT knowledge, this is hard. Yeah. So there's a mental mismatch right now for me. Why should I use this when it's so hard and there are so many complicated things, when I just can use a WAR file, deploy it somewhere? Yeah,
you're right. It's also for me, it's on the first side, Docker is a very easy technology. If you build images, this packaging thing is easy. But what you package is hardcore IT knowledge. And I have reviewed a lot of Docker projects, and when you see what people package, it's amazing. And you need a lot of good knowledge about the software that you package. If you package a Tomcat, you can make a lot of mistakes. If you package MySQL database, you can make a lot of mistakes. That is what I mean is the hardcore knowledge. It seems easy, it's easy, but you must know what you do. And on the end, the complicated part is to build platforms. Yeah, and that's really, really complicated.
What's the actual...
these tightly services and so, that's complicated.
What's the actual advantage then?
The advantage is the easy packaging. You can move around your installation from one installation to another. It's so easy for integration tests on your laptop to simulate the situations that you have really in production or one customer have in production. You can, after a while, you have identified, this is my MySQL, my Redis, and so installations, and it's so easy to start it, to play around with these technology in the new services, and that is the value that I think you can have. But on the other side, to build good software is hard. That is what I say. The tool set cannot help you, but it's better as before. I can show you some interesting experience on Puppet or so, and it's not so amazing. Another question? Yeah. But it's a good one question.
What's your story about autoscaling? I didn't get it.
Autoscaling, yeah. Autoscaling is another very clever topic. It comes in the latest version as experience level on the Kubernetes stuff, with a very, very easy strategy to measure the CPU of every container, and if the CPU have on all containers reach a barrier, then you start another ones and have a very slowed down container reuse strategy. But they work on the 1.2 release that you have can build a plugin for this matrix, and then you can have a more clever strategy for your current need, like space or memory or I/O, and so to these rescaling, auto-scaling stuff. It's not like Elasticsearch, Amazon load balancer. No. I think Google can do that, but they don't want. Yeah, nice. I hope I see you on the conference. Thanks.